So we have two inputs for this problem. So first one is the temperature being sensed by your car. It's about the weather temperature, okay? And input 2 is about the cloud density. So it's about the weather, okay? If it is about to rain or the clouds are thick, something like that. Because we know if the cloud is thick or the appearance of the clouds in the sky is thick or dark, we know the tendency that rain will come, right? So these two inputs will affect how fast the driver will do the driving based on the calculation or the computations we're going to perform between temperature and the cloud density. And so all of this, we have to fit it in our fast system, okay? And we will be doing the calculations later on. So if you remember on the past discussion, we have these categories of the temperature. Under the temperature, we have three categories: freezing, cool, warm, and hot. So we have 4 categories for the temperature: freezing, cool, warm, and hot. For the cover, we have these 3 categories, which is sunny, partly cloudy, and overcast. For the driving, this is the output. Let me just write a note here so that you will know what I'm pointing out. So this is our first input. This is I1, and this is our input 2. Okay, so we only have one output. Okay, so this output will be either slow or fast. Normally, in this example, I think they want you to determine miles per hour. Okay, so how fast would be the driver? Miles per hour. So we want to represent how fast, okay, the driver should do the driving based on these situations here, based on the temperature and based on the cloud. Okay, so we will be determining later how slow would be and how fast would be the driver in doing the driving. So as we remember last meeting, we're only reviewing, okay? We haven't done the calculation yet. For those people who are not here last time, we're just doing the calculation only. So for the temperature, we represented our membership functions into this way. For freezing, we have this, okay? So this drawing here from this up to here is for the freezing, and from here up to here is for the cool, and from this side up to this side is for the hot. Okay, I hope you can see what I am pointing here. And then for the sunny, we constructed also, for the cover, we also constructed our membership functions. So sunny is like this, okay, and then partly cloudy is like this, and overcast is like this. So this will be our cloud cover in percentage, okay? And temperature is represented in Fahrenheit. Now our driving, the membership function for the driving is very simple. We only have 2: slow and then fast, okay? So I discussed this last meeting. I'm only reviewing back for those who were not here last time. So we will now try to calculate later on, based on the inputs, what would be the driving speed of the driver based on this given diagram here. So these are the rules, okay? The rules will be like this. So the driving of the driver will be based on the following rules. If it is sunny, okay, if it is sunny and then the temperature is cool, we have to drive fast. It's okay to drive fast if the cover, meaning if the weather is sunny and the temperature is cool, then we could drive fast. This is the rule. Then the second one here, if it is sunny also and the temperature is hot, and then you could drive fast. So this is the ruling here. Then if it's cloudy, the weather is cloudy and the temperature is warm, and then we have to drive slow. So another rule here is if the weather is cloudy and then the temperature is cool, so we have to drive very slow. So these rules, actually you could add other rules, okay? So these rules are not fixed in here. So depending on the problem you try to solve, your rules could be 4, could be 5, could be 6, depending on how complex the problem you want to solve. But for this exercise, we will be only using four rules for the discussion. But in real life, you could encounter more rules, around 5, 6, 7, 8, 9, 10, depending on how complex the system you want to represent or you want to calculate. Okay, just to make this discussion very easy for you, we'll be using few rules only. So we have a given here. Let's go with the given. We're now on step 4, which is we're going to convert the script inputs into the fuzzy values. And the conversion of crisp inputs into fuzzy values is only possible if you understand how our functions works. Okay, so I discussed them to you last meeting, so you have to follow me up later as we go with the discussion. So please take note, our given is 81 degrees Fahrenheit for the temperature, and the weather is 23% cover. So 23% is somewhere here in sunny, right? So it is sunny because 23 is somewhere here. And also, it is also cloudy, right? Because if you're going to check the values here, this is around maybe 23 somewhere here. So, and temperature is 81, so which is somewhere here. Okay? So if you will look at it, if you look at the given problem here, 81 degrees Fahrenheit is both falling with warm and hot, right? Because it's in between the triangle. If you will check at this image here, if you're going to check the image here, 81 is within this triangle, so it is warm, right? And 81 also is within the hot, because if you're going to draw this figure here, it means that 81 is also within the warm. So meaning this 81 Fahrenheit is hot and warm at the same time, right? So it's hot and warm at the same time. So later on we have to calculate it so that we will determine, is it really hot or is it really warm? Later on we will go into it. And then on the weather, if you will see, 22% is lying between sunny and partly cloudy, right? So it has two descriptions. 23 is either sunny or partly cloudy. So we have to calculate these values now based on our, what do you call this one? Based on our membership functions. So our goal now is to arrive into conclusion, okay, into this. So we have to convert it into this form. So how did we do that? So let me just copy this one first. Let me just copy this, and we will calculate it in the whiteboard so that you will know what I am discussing here. Let me just erase this for the meantime. So let me go with snipping tool and just get the snipping tool here. And let me just copy this portion, and let me put it in the whiteboard. Okay, so we have this. Okay, so let's try to see the values for the hot, okay, and for the warm. Okay, so look at this. 81 is lying between warm and hot. Let's try to calculate first warm, okay? So let's get the fuzzy values. Okay, so let's go back with our membership functions here. If you will see, warm, what kind of membership function it is using? It's a triangle, right? Correct? So it's a triangle. So let me draw it so that you will see it. For the sake of those who are not here last time, let me just do it. So warm is this 50 and 90, right? So let me just draw it. Oh, Control Z, not this. Okay, so we have this, right? So it is, here is 50 and here is, we have 90, right? Correct? So our value is somewhere here. So this is 80. 81, right? This is 81, I guess. So 81 is somewhere in this point. So if I'm going to divide the triangle into this, so 81 is somewhere here, right? So please make note of these values because we're going to calculate them later. So this is 50, this is 90. So let me scroll you back with our discussion last time. So we're going to follow this, right? Because it's a triangle, correct? So it's A, B, C. So let me just draw here. So we will have here A. This is A. And we have the B. Paste, we have the C here, okay? So our X is actually 81, okay? So this is our X now. X 81. So what will be the fuzzy values of 81? So you have to remember, my friends, fuzzy values should always be 0 to 1 only, okay? If your value is more than 1, let's say for example 1.5, I'm pretty sure your calculation is wrong. So look at this, please check this one out. So 81 is in which position? 81 is between B and C, right? Correct? 81, the value of 81 is between B and C. So let's see what will be 81. Based on this formula that we discussed last meeting, if we go back, 81 is here, right? This. So it's between B and C. Therefore, which one we're going to use? This one, right? We're going to use this because X is between B and C. So we have to use this formula here. So we're going to use C minus X over C minus B. C minus X over C minus B. So we're going to use warm. So warm will be C minus X over, I forgot it, C minus X over C minus B. Over C minus B. Okay, so we have to do this. C minus B. Okay. So, but in this example, what is B? What's the value of B? Look at this one, please. The value of B is A, B, C. So the value of B is 70, right? So based on this figure, the value of B is 70. Okay? So look at this. So we're calculating for the warm. So in this example, this is warm, okay? Oh, Control Z. So this is warm. Okay? So warm will be 50, 70, and 90. Okay. So let's try to calculate the value of warm, which is X. Okay? So in this case, what will be the value of X? So you just have to substitute here. X would be C, which is 90, minus X, which is 81, divided by C minus B, which is 90 minus 70. Calculation. Okay, I repeat, for those who are not here, since X is between B and C, you just have to go to your figure here, the formula I discussed to you last time, here, okay? Okay, with this. We're going to use this. It's between here. That's why we got this equation here. Let's now try to calculate it. What will be the value of X? X would be, go to your calculator. So this would be, close parenthesis, 90 minus 81 divided by, close parenthesis, 90 minus 70. So the value of X would be 0.45. Did you get the same answer like me? 0.45. 90 minus 81 divided by 90 over 70. Okay, so it will be 0.45 based on my calculator. Did you get the same calculation? Did you get the same calculation, ladies and gentlemen? I hope you had the same. Okay, so this is for warm. Next, let's calculate for the warm, but this time for hot. Not for warm. I'm referring to hot here. Let's calculate for hot. Hot is using what? Trapezoid, right? So it's using trapezoid. Hot is using trapezoid here. So look at this. Okay, we're now going to calculate for hot. So hot will be using trapezoid. Okay, so please make note of this one. So this is hot, is using trapezoid. So let me draw this. Let me draw our trapezoid. Okay, so these are trapezoids. Let me just do a drawing in here. So based on the given, we have 70, 90, and 110. We have 70 for this, and we have 90. So we have here 90. And then we have 110, right? This is 110. Okay, good. So we are calculating for the same value of X, which is 81. Control C, Control V. Where is 81? 81 is somewhere here, right? In between these two. So this is 81. 81 is between 70 and 90. So if you remember on the past calculation, this is A. So A is here. And then B is here. And then we have another one which is C. Okay? So all the points here, A, B, and C. Okay? So which formula we're going to follow based on the presentation last time? So let's go back to our chart. You have to remember, X is between A and B. Okay? It's between A and B on this example. So let's go back here. So it's here, right? So X is between A and B. So what's the formula? The formula is this one. We're going to use X minus A divided by B minus A. So we're going to use the formula. Okay, so therefore our x will be this, which is for the warm, I mean for the hot. So hot is like this. Okay, so we can now calculate it. So let's try to substitute the values. Okay, so x hot will be how much here? So you just have to put the values here, again here. So what will be the values? So in this case we have x minus a, which is 81 minus a is 70, divided by b minus a, which is 90, b minus a, 90 minus 70, right? So you should get a value here. So this will be close parenthesis 81 minus 70 divided by 90 minus 70 equals this one, which is 0.55, equals 0.55. Okay, so this should be the values that we're going to get. Good. Let's now calculate for the cover and the sunny. Okay, so let's try to calculate it. So let me just go with sunny and cloudy. Let me just copy this so that we won't be moving too much here. Okay, so our focus now is on the cover. Okay, ready? So based on the discussion, 23, okay, 23 is between sunny and cloudy, so we can calculate this, sunny and cloudy. Sunny, for the sunny, again we have to note, okay, sunny is here. Let's go with the image. Let me just go back with the PowerPoint. So it's using trapezoid, right? So this one, we're going to use this trapezoid for sunny. So this is using trapezoid, right? So it's using trapezoid. But look, the way the trapezoid was drawn, A, B, C, and D, right? So we have to draw with this. So let me just draw another imaginary line here. So in this case we have B, we have D here, we have C, we have Control Z, we have B. Okay, since we will be following this this one, let's put the values. Let me just put it on top so that it won't disturb us. What's the value of x here? X is how much based on the example? It's 23%, right? It's 23%. X is 23%. Sorry for this. So we are calculating for this one, 23%. This one. Okay. So let me just note what's the value of B. B is 0. This is 0 for B. How about the value of C? It's 20, right? So this is 20. How about the value of D? It's 40. Okay, so this is it. 0, 20, this one here is 20, and we have the end is 40. So 0, 20, and 40. So we're calculating for the value of 23, right? So 23 is somewhere here. So this is here. So X, which is 23, is between C and D. Therefore, we're going to use the formula, which is what? You have to remember, it's between C and D. So C and D is here. So look at this one, C and D. So X is between C and D. Therefore, we're going to use D minus X over D minus C. D minus X over D minus C. Okay, so we're going to use this formula for Sunny. So we can now go with the calculation of X. Okay, so the value now of X would be this for Sunny. So let's try to calculate it. So not to confuse you, let me just call this one also Sunny, okay? No problem for that. So D minus X, D is 40, minus X, which is 23, divided by D minus C, which is 40, minus C, which is 20, right? So for the sake of uniformity, let us just change this also to hot. Shall we calculate this? So the value of Sunny would be, I'll tab calculator, clear this, close parenthesis, 40 minus 23 divided by 40 minus 20. So we will get this value as D 0.85. 0.85. Correct? Let's go with Cloud. So based on this illustration, Cloud is using a triangle membership function. So we have to draw a triangle here. I'm sorry, my triangle is ugly. So let's put something in between, a line in between. Okay, so based on this, we have to write A here, this one is B, and put them inside so that it's not difficult for us to see them later. See here. Okay, so based on the given problem, the value of A is 20, and then we have the other one is 80, 20, 50, and 80, right? Because the half of this is 50, I'm sure, right? So the half of this will be 50. So this is 20, and this one is 50. then the other half, the other end I mean, will be 80. Okay, so this will be 80. Now where's the x? X, as the given here, x is 23. So 23 is located somewhere in this place between a and b, right? So using the triangle membership function, which is this, so 23 is between a and b. Based on the problem here, it's between a and b, so we'll be using this formula, a and b, between a and b. So we're going to use x minus a over b minus a. X minus a over b minus a. So this is for cloudy. Okay. So cloudy here would be x minus a over b minus a based on the formula there. Now let's try to calculate it later, but for now let's try to substitute the values. So sunny equals which one? It says x minus a, which is 23 minus a, divided by b minus a, which is 50 minus 20, right? Let's check the values if it's correct. X 23 minus a, which is 20, over b minus a, which is b is 50 and a is 20. So we can now do the calculation here. So sunny is what value? Let me just get the calculator. So this is close parentheses, 23 minus 20 close, divided by 50 minus 20 equals 1 over 10, which is 0.01 or 0.10, 0.10. So we're done with the calculation. We were able to calculate the we were able to convert the crisps inputs into the fuzzy values. Okay, so let's now proceed to the next step of the fuzzy logic process or algorithm. Okay, let's now go with the next one. So I hope all the values we got properly. Okay, so these are the values you've got from the previous calculation. Let's now try to evaluate. Okay, let's now try to evaluate the rules. Let me just get this rule so that you can follow me with the discussion. Okay, let's now go with the evaluation of the rule base. Okay, so let's try to look at this. So we have the first combination, which is warm, and sunny, right? Let's see here what's the combination. Sunny. Okay, we have sunny and cool, right? So we have the combinations here. So try to check which of these were followed in the rule base. So look at this. So the first combination we have is hot and sunny. Let's see which one is here. Hot. The temperature is hot, right? So we have here hot. It says hot. And then the other one is hot first, and then we have The second one is sunny, right? Hot and sunny. So hot and sunny. So we have to highlight this. So the first combination is hot and sunny. So sunny and hot. So we're going to highlight this. Okay. Next, what's the next one? The next one is warm and cloudy, right? So we have cloudy and warm. So we're going to select this one. The note here. This one and this. Okay, so you just have to look at this. And this one and this. Okay, these are the combinations that we have. It's hot and sunny and warm and cloudy. So based on this, hot and sunny, try to look here the combination. Hot and sunny. Okay, then we have the second combination, which is warm and cloudy, which is cloudy here and warm here. So rule based match. Okay, so we have these rule based matches. The first one is sunny, and this symbol means and, okay? Based on your discrete structure class, you know what's the meaning of this symbol. So this is sunny and hot. And the other rule match would be, so we will going to derive fasts. Okay, and the next one we have cloudy, and we're going to use and, which is warm. It says warm, so we have warm here. So we need to drive slow. Okay, so it's now confusing, right? So based on these rules, sunny, hot, and then cloudy, warm, it says slow. So we don't know which one to follow here, right? Because it's fuzzy. So let's now try to evaluate. Okay, we're going to evaluate it, which is the next step. Let me just go with the PowerPoint. So we're going to evaluate the rule base, so we will have to get this. Okay, the one we selected earlier. So we're going to choose this, the two, this one, sunny, and this one. So to combine the results from each rule, if it is sunny and hot, drive fast. This one, right? So this is what we have selected earlier. So later I'll discuss to you how to get this. Okay. Okay, so if you will see, this is using and, right? So this symbol here, let me just take note. This symbol means and. Okay. So if you will see this symbol, this one means or. Okay. So let me just discuss to you first the meaning of these two, and and or. So based on the truth table, if you remember your truth tables, okay, in and operator, what happens? 0 and 0, what is the value? It is 0, right? 0 and 1, the answer is 0, right? And then we have the next one, 1 and 0, the value is also 0, right? 1 and 1, the value is 1. Please remember this, the truth table. How about the OR? In the OR, it's different, right? 0 or 0, the answer is 0. 0 or 1, we have 1. And then 1 or 0, we have 1. And then 1 or 1, we get 1. Why am I discussing to you this truth table, or these truth tables for AND and OR? Because you have to remember, in exam, sometimes it's not only AND that we use. Sometimes we use OR, okay? That's why please make note of the symbols used here. If this is like this, then we are talking about AND, okay? This one, this means AND. If the symbol is like this, an inverted symbol like this, and then you will be working with OR. So please be careful. The way we evaluate rules will be based on the operator that you're going to use. So for this example, we're going to follow the truth table of AND. So in the AND, 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0, 1 and 1 is 1. So if you will notice, in the AND truth table, we select the higher value, right? I mean, we select the lower value, correct? Correct? We select the lower value here. So you will see 0 and 0, we get 0. 0 and 1, we get 0. 1 and 0, we get 0. 1 and 1, we get 1. So in the OR, we select the lower value for the OR. Okay? I mean in the AND, sorry for that. So in the AND, we select the lower value. In the OR, we select, obviously, the higher value, right? So look at this one. So 0 or 0, we get 0 because both of them are 0. 0 or 1, we select 1 because based on the rule of OR, we normally select the higher value here. So 1 or 0, we select 1 because 1 has the higher value. So please remember these sentences I have written here. In the case of AND, we select the lower value. In the case of OR, we select the higher value. Here, lower. Here, we select the higher value. Now, we're going to evaluate the values that we had earlier in the discussion. Okay? So, using the truth tables that we've got here, we will try to evaluate the rule-based. Okay? So, evaluating, let me just copy these two here. Okay, so let me just copy this. Let's try to evaluate. What's the value of Sunny based on the discussion earlier? What's the value of Sunny? Can anybody tell me the value of Sunny? Sunny is how much? 0.85, right? How about the value of hot? The value of hot is, the value of hot is 0.55 here. hot is 0.55. Okay, so which are we going to select? You have to remember, in AND we are selecting the value which has the lowest, right? So meaning we're going to select 55, 0.55. Okay, therefore we have to drive according to this. Which one? We're going to drive 0.55 fast. Okay, it's based on this. How about in the case of cloudy and warm? What's the value of cloudy? The value of cloudy, based on the calculation, cloudy is how much? 0.10. So we have to write here 0.10. Cloudy is 0.10. And warm is how much based on the calculation? Warm is 0.45, right? Am I correct in this? Cloudy 0.10, 0.10, and then for the hot is, for the warm, 0.5. Is this correct? 0.10 for the cloudy, and for the warm we have 0.45. So which one we're going to select based on the rule? 0.10, right? Because 0.10 is low. So it means that based on this we have to drive 0.10 slow. So done with this. So if you will look at this result of the FASI calculation, we have two results, right? According to the inputs of our FASI system, you have to drive fast according to this. But how much fast? It says 0.55 fast, or simply we could say 55% fast. And then it also says slow, which is 0.10 slow, meaning you have to drive 10% slow. So the problem is we don't know. Are we going to drive fast or are we going to drive slow? So we need to go to the next step to tell us how much speed we're going to drive for this given outputs. So you have to remember it says 0.55 fast and 0.10 slow. So the next step of the FASI logic system. Okay, so we got this. Okay, so let's now try to defasify, meaning when we say defasify, we have to convert FASI data into non-FASI value. So from 1, 0 now, or from 0 to 1, we have to convert it to real values, okay? So what is 10% slow or 55% fast into real value? So we have to get, is it 25 miles per hour or 50 miles per hour or 75 miles per hour? So we have to know which value we have to drive. So we're going to use centroids, or the measure of central gravity, for the calculation. Okay, so I will teach you how to do that. But for the meantime, let me copy this. Let me just get this. And we're going to calculate. Okay. So we are on the last stage. Okay, so this is a representation. 10% slow and 55 fast. Let's try to calculate it using the centroid. Okay, then we will get the value. Okay, let's try to calculate this. So let me get this drawing because I need this very much. Let me magnify this. Okay, so we have 10.10 slow, right? And we have 55 fasts. So meaning if I'm going to divide, if I'm going to redraw this, but how could I just get only this? I need only this part. Let me go with the PowerPoint. I only need this part, this one. Okay. So in the defalsification, we're going to use central of gravity, okay? So we're going to defalsify using central of gravity. We have this technique. We have plenty of techniques for defalsification, but we're going to use the easier one for you, which is central of gravity, or COG. Okay, so based on the example here, it says we have 10% slow or 0.10 slow. So we have to make, if I'm going to divide this into 5, so this is 0.5, right? This is 0.5. Which is also equivalent to 50%, right? This one. Can you see my screen clearly? So this is 0.5. If I'm going to divide this would be how much? So 0.10, this is 1, 2, 3, up to 10. If I'm going to divide this would be around 10, right? 10 divisions. So this is 0, this is 1 here. 0.1, 2, 3, 4, 5. Okay? I'm assuming we are doing equal division here. And then we have here 0.6, 7, 8, 9. Okay? So if I'm going to draw a line, it means that we're going to calculate it. It means that slow is somewhat 10%, right? Based on this given here, slow is 10%. So I have to go somewhere 0, 1, this. Okay, for the slow. Then I have to draw a vertical line here. This is 0.10. So I have to draw a line. Okay, so this is 0.10. So it means that this is 0.10. 0.10 or 10%. Okay, so this is 0.10. Okay, this is 0.10. And then fast is how much? Based on this, fast is 55. So this is 0.5. As I discussed to you earlier, this is 0.5. So you have to place it somewhere in the middle. Therefore, 0.55 is somewhere here. Here on this line, right? So you have to go with the ruler. So 0.55 is somewhere here for the fasts. So fast is somewhere here. Okay. Since slow is 10% or 0.10, this actually also 0.10. Okay. This also synonymous to 0.10. This also 0.10. Okay. And this one is also 0.55. Okay. So I've divided this image here into 10 parts. Now, so you will see it has 0 to 1, right? So I divided this into 10 parts: 0, 0.10, 20, 30, 40, 50, 60, 70, 80, 90, and 100, or 1. So I divided this. So slow, according to the output we have, slow is having how much? Is 10%, right? 0.10. So this is 0.10. I wrote it in here, 0.10. That's why you will see it says I highlighted all the slow only. Okay, 0.10 of the slow up to here. Okay, so I've highlighted this. So 0.10 will be from here up to here only, because slow is from 0 to 75. That's why I highlighted 0 and 10, all of this area. So if I'm going to highlight this, this is for the slow. Okay, this slow only. Clear? Then we have fasts. According to the problem that we had, fast is how much? 55%. So since this is 50, so I am assuming that 55 is somewhere here in the middle between 0.6 and 50, right? So this is 0.6, so the middle is 0.5. So this is 0.55. Let me just write a note here. So this is 0.55. This line is 0.55. Okay, so I could highlight now all the values for the bold, for the fasts. Okay, so let me highlight so that you will get it. Let me just change the color to somewhere like this to represent fast. Control Z. So all of this area belongs to, okay, fasts. Okay, so let's now calculate it. We will now calculate this based on this. So in the center of gravity, okay, in the center of gravity, you have to include the weights. Okay, Control Z. Let me just get a note here. So look at this side. Okay, so calculate all the values from 0 to 75 for slow. Okay, so we have here, so COG now would be this calculation. First we have to go for the slow, close parenthesis here, 0 plus 25 plus 50 plus 75. Agree? For the value of slow, 0, 25, 50, 75. Because this is the area highlighted for slow. So you have to multiply it by the weight, which is, what's the weight? 0.10. Okay? Like this. So this is how we calculate it. So 0 plus 25 plus 50 plus 75, this multiplied by the weight, which is this, 0.10. And then we're going to add it with the value of fasts. Okay, this is for the fast now. Let me just write something here so that you will see this is for the slow. This one is for the slow. Let me highlight it so that you will know what I'm calculating. Okay, then for the fast we will do the same. We will have to calculate all the values for the fast, which is 25, not 0, okay, because 0 is not part of the fast, only 25. It starts with 25 up to 100. Okay, so 25 up to 100. Don't include 0 here because it's not part of the fasts. 25 plus 50 plus 75 plus 100 multiplied by the weights. What's the weight? Is 0.55, right? 0.55. So let me just highlight this. I hope you could see what I'm doing here. So this is for the fast, okay? Please look at this. This is for the fast. Let me highlight the values for the fasts. So all of this would be for the fasts. Okay? Finished? Not finished yet. We have to divide it by the total number of weights. Okay? So we have to divide it by this. Divided by this. So how do we divide it now? So we have to do this. So how many were for the slow? We have 1, 2, 3, 4, right? 4 values of the slow multiplied by the weights. Okay? How about here for the fast? We have 1, 2, 3, 4, right? So we have to write here 4 multiplied by the weights, which is 0.55. Okay? So this is how you will do it. You have to count the number of cases. 1, 2, 3, 4. This one multiplied by 0.55. And this one 1, 2, 3, 4 divided by, multiplied by 10. Okay. So we can now proceed with the calculation. So you have to start first with the top, then you will go with the total answer. The final answer. So COG here equals, tell me, for the first part you will get how much? For this, let's try to calculate this. Clear. Let's get with it. Close parenthesis. 0 plus 25 plus 50 plus 75 close parenthesis multiplied by 0.10, we will get 15, right? So this is 15. Then the next one here, how much? This is 25 plus 50 plus 75 plus 100 equals this multiplied by 0.55. We will get this, which is 137.5. 137.5. Then let's try to divide it by the value. Let me just put it for the meantime here. Let's divide the value okay, which is how much? So this at the bottom we can calculate straight by doing this, close parenthesis, 4 times 10 No, this is 0.10. Okay, I'm sorry, this is 0.10. Sorry for that. This is 0.10. Sorry. So going back, so this should be 0.10, 0.10 plus this one, 4 times 0.55. So we will get something like this, 2.6. Okay, so we can now finalize the answer. So COG would be equal to, let's calculate it. We'll get close, this is close, so we just have to add it, 15 plus 137.5 divided by the value here, which is 2.6. we will get this, which is 58.65. 58.65. So meaning we're going to drive, therefore we could conclude the driver should drive what? Should drive fast or slow? 56.8. What is this, slow or fast? 58.65 is somewhere here. 58.65, right? So we don't know if it is fast or slow, right? Correct, 58.65, because both of them are slow and fast, so the combination of the two. But what we know is that we know that the driver should drive how much? Based on this, the driver should drive around 58.65 miles per hour. This should be the speed. Okay, so we are now solved. So the driver, after the computation, we could say that the driver could follow the speed limit. The speed limit would be 58.68 miles per hour. Okay, so based on this example, so after the calculation, we were able to conclude that the driver should drive 58.68 miles per hour. Okay, so the driver should follow this strictly, 58.68 miles per hour, after considering both the values for slow and the values for the fast. Next meeting, we will be doing another example, which will be tomorrow, God willing. We will be doing the same example. I'll give you another example for this. And thank you so much for your time, for attending this today's class. Thank you so much, and masalam.